Hey guys, so like I just said, wanted to get you guys back into the lab. The chapter we're working on with the whole notations and subatomic structure, all good stuff, doesn't lend to a lot of experimentation. So the lab that we're going to look at here today links a little better to some stuff we already covered. So the good news is it'll be mostly review. The bad news is that it's not directly related to what we're currently learning. But the moral of the story is we came off a chapter where you guys learned about solution chemistry, that when we take solids and dissolve them in water, some things break up into ions, some don't. Things that don't break up are precipitates. Things that are breaking up are called aqueous. So we can use that to our advantage. For instance, there is a method known as gravimetric analysis. And gravimetric analysis is usually used to identify an unknown substance. And you do it by being able to ascertain the substance's molar mass. What we're going to do in the lab today is we're going to identify a group 1 metal that's attached to a carbonate. All right, so we don't know who it is, but we know we've got some metal from group 1, which would be a +1 charge, combining with carbonate. One of the best ways to identify an unknown is to get its molar mass. So if you look here in the green, the molar mass, right, is the grams of the unknown divided by the moles of it. Right? Luckily for us, metal carbonates are ionic compounds. Therefore, their natural state tends to be a solid because they have particularly strong IFs, an ionic bond. That means it lives as a white crystalline solid. That's easy enough to get its weight. All we have to do is gather up a sample of it and put it on the balance. So we will know the grams of M2CO3 within about 10 minutes of doing the lab. The moles are a bit trickier. Right? Because we don't know who the metal is, we're going to have to find another way of getting the mole substance of the M2CO3. So I always say, if you can't get the substance itself, the next best thing is to get a substance in an equation with it, because you know you can do a mole-to-mole ratio. So if we take a reaction, for instance, M2CO3, our metal carbonate, which is soluble because group 1s are always soluble. So this guy, he lives as ions in solution. I'm going to put it with calcium chloride. Again, group 17 soluble, calcium not an exception. It's going to live as ions. When I mix those, I'm going to double replace, and I'm going to create calcium carbonate and some metal chloride that I don't know, but I do know the metals from group 1. So I know my metal chloride is going to stay in the ion form because group 1s are always soluble with no exceptions. The calcium carbonate, calcium doesn't have an individual rule. Carbonates are generally insoluble. That means this guy's going to be a precipitate. And because he's going to precipitate out, that means I can gather him, dry him, and see how much there is. And there is the substance I'm able to calculate moles of. And as soon as I get his moles, I can 1-to-1 ratio the CaCO3 into M2CO3. All right, now a couple of things to make sure that we get the exact amount. I'm going to set up the experiment so that the metal carbonates are limiting reactant. We want every last bit of carbonate that's in here to end up in here. That way my precipitate and my metal carbonate are a true 1-to-1 ratio. That means I'm going to make the calcium chloride my excess, which I don't really care if there's extra calciums floating around, because that's not the metal I'm concerned with. And there's going to be chlorides no matter what, because it's in a soluble product. So this is the theoretical end of what we're doing in the lab. All right, I'm going to take my unknown, I'm going to react it with a substance that I know will make a precipitate, gather the precipitate, figure out its moles, and then I can bracket problem it into this. Once I get the number value for my metal carbonate, all I have to do is extract the 12.01 of that number, that's carbon, and the 48 grams of it, that's oxygen, and I'll know what the weight of 2 of my metals are, and I can pull it from the periodic table, all right, which is above. All right, so there's the theoretical. Here's the physical end of what we're doing. All right, we're going to go back into the lab. All right, and step 1 says drive off H2O. So I'm going to take roughly 2 grams of my metal carbonate and I'm going to put it in a balance. Because it's ionic, very often there's waters attached to it. So we need to make sure it is truly, in fact, just the metal carbonate. So I'm going to heat the thing with my Bunsen burner to drive off any water. And then I'm going to see, do I really have 2 grams or is it a little bit less than that? Once I get it to be dried, then I'm going to immediately put it into a 400 milliliter beaker, right? And it's going to be 200 milliliters of distilled water and then 125 milliliters of calcium chloride. All right, the 200 milliliters simply makes sure there's no other substances in there that we're concerned about. And the calcium chloride initiates the reaction. When that happens, you are going to see a precipitate based on the equation we just listed. So I'm going to get that same beaker, but I'm going to have some solid spread throughout it. It's going to look milky white, but the milky white is because we're forming a precipitate that hasn't settled to the bottom yet. But there's going to be other stuff in there. Like we said, the calcium carbonate's the precipitate, but you're going to have leftover calcium ions from the excess reactant, and you're going to have the MCl compound break down because it's soluble. So what we need to do is isolate the precipitate, right? And luckily for us, it's a solid, and it's the only solid in the setup. So I'm going to take that substance, and I'm going to dump it through a funnel that has a piece of filter paper in it. And what will happen is the filter paper will catch the solid and it will let the ions and the water run through. And the name of that stuff that goes through is called the filtrate. So if I ever ask you what's the filtrate, it means what made it through the filter. The precipitate gets stuck to the filter. So what I can do then is take my filter paper out of my funnel, and what I should have is filter paper with calcium carbonate, right, on the filter paper. Now, it's going to be wet, so we'll have to dry the thing, right? But when I dry the thing, I will just have filter paper with pure CaCO3. So there's a little bit of water on that as well in that step. All right, so I'm going to take you guys to the back. I'm going to walk you through it. The good news about not having to do this in person is gravimetric analysis tends to be kind of long and tedious. Even if we use a vacuum filtration system, it usually takes 40 or 50 minutes to filter it, but I could do all that ahead of time. All right, so you guys are going to have to wait to see it filtered. You're going to get just the nuts and bolts of what you need. All right, so I'm going to take you guys to the back with me. When we get back here, just kind of a quick look at our setup. All right, I've got my balance, which we'll be using. Here's some filter paper, some beaker tongs. All right, but I'm going to set you guys up right here, and I tip you down, and I'll angle this, all right, so you can see what we're doing. So the first thing that we want to do is we need to get ourselves a crucible, all right, so that we can dry this substance. All right, so the first thing I'm going to do is going to go into a lab drawer. Going to get myself a crucible. All right. If you're following along with the procedure, all right, the first thing it says to do, all right, after step 1 is set up a Bunsen burner and a ring stand with it able to hold the crucible, all right, like this. All right, then it says light the Bunsen burner, all right, and brush the bottom of the crucible, all right, for about a minute, all right? And the whole point of this is just to burn off anything that might be on our crucible. All right, so I'm going to turn this on. Light my burner. And then I was going to come over here, and I'm going to gently brush my crucible, driving off any humidity that might be on there, and getting rid of that substance. All right, so the last 30 seconds, I'll just let it sit and really get that thing going. All right, and then I can turn my burner off for a minute. This guy's going to be too hot to touch with my hands now, so I'm going to have to grab my crucible tongs. All right, and then steps 4 says using the tongs to handle the crucible, get the mass of the empty crucible. So I'm going to move this guy over to my burner, zero out my balance rather, putting it on my balance. Reading that number off 2. This is what's going in the 4th line down on your data table. All right, so the number we're getting there is 10.73. All right, so 10.73 is the mass of my empty crucible. All right, now it says while that's still on there, I want to add approximately 2 grams of the unknown carbonate. Okay, so I'm going to go ahead and do that. All right, and it doesn't have to be perfect, right, because we're just going to measure the crucible before and after to get exactly what's in there. All right, so I got it in the ballpark there. So this 10.73 is now reading 13.11. So your very top line of your table is 13.11. So I overshot just a little bit, but it's not a big deal. All right, we just wanted a ballpark of 2. All right, then it tells me, okay, record that number. So make sure you have your 13.11 in the top line of your data table. All right, step 6, it says move the crucible to the pipe stem triangle, all right, and then lightly hit it for 2 to 3 minutes, all right? And the whole point there is to get rid of any water that may have attached. Right, so I'm going to return on my burner, put it on there, getting the time on the clock. I'm going to let 2 to 3 minutes go by. While that's heating, always keeping an eye on it, but looking where we're going next. Then I'm going to come right back and I'm going to weigh the crucible on the balance, all right, to see if there was any change in the weight. All right, I'm going to keep going through that process till I get a consistent weight, right? Because if there is water on there and it is leaving, we want to make sure it's all gone. So I'm going to heat for 2 minutes. Then I'm going to get the mass, then I'm going to heat for 2 and get the mass, unless we happen to be fortunate enough, right, that our crucible, after we heat it for a minute, happens to be the same. So we still have about a minute to go there. And all we're doing right now is prepping. We're prepping the M2CO3 for the reaction with the calcium chloride. Every once in a while, just move that flame, brush it. All right, and there's my 2 minutes, all right? So I'm not going to shut my burner off this time because there's a chance I have to come back up on. All right, so I'm going to go over here. Bring this over. All right, and then I'm going to get my number. This time the number is reading 13.10. All right, so we lost a very tiny bit of mass. We went from 13.11 to 13.10. I'm going to say that is close enough to say we are good. We have heated it enough. All right, so I'm going to shut off my burner. Move my ring stand out of the way. And it looks like we're able to push into, all right, step number 9. And it says, add the crucible contents to a 400 milliliter beaker, and then add about 200 milliliters of distilled or deionized water, all right, to do that. All right, so I'm going to grab myself a 400 milliliter beaker. All right, here's my 400 milliliter beaker. I'm going to take my crucible, and I'm going to dump my contents into it. Now it says to add about 200 milliliters of distilled water. All right, so if I go ahead and I do that, and that's over here, so bear with me a second. All right, so we're trying to make the solid dissolve. And if you take a look here, we're not quite dissolved yet. So I'm going to give it a little bit of a stir. All right, but I'm going to just speed that up by doing it in the back with a hot plate with a stir rod on, like you guys did for your lab. All right, so give me a second to go do that. And that's going to take a second to happen. So I'm going to walk you guys back so you can see what's going on. So we go back here. Set you guys up. All right, using my stir rod, my stir bar, right, to get that calcium, to get that unknown carbonate, all right, to dissolve. All right, it looks like we're getting close, so I'll go ahead and turn that off. And then what I'll do is I will reach in with my stir bar retriever, grab the stir bar out. All right, set that down. And now we're headed back out to the lab. All right, so what you guys have here is our dissolved metal carbonate, where we don't know who it is. All right, now we're into step 11. It says add about 125 milliliters of CaCl2. And it doesn't matter if it's perfect because I'm making the CaCl2 be in excess. All right, so here's my calcium chloride. And I'm going to add it to get about 125 more milliliters. So I'm going to take my 200 up to 325. And sure enough, you can see that this has now become a milky white solid mixture, right? You've got the precipitate in there, but it's sort of spread out throughout the liquid. All right, so it tells us, let that thing precipitate out for 5 minutes. All right, so this is where we can speed things up. Let's assume I've let that precipitate for 5 minutes. And what it'll look like after 5 minutes isn't all that much different. Looks like this. All right, so we've got this still white solid that you can see is like starting to aggregate to the bottom, if you're looking at the bottom there. All right, and now we're all about trying to retrieve that solid. All right, so this is going to be over here waiting to be retrieved. All right, in the meantime, what it tells us to do is to go and get a piece of filter paper. And it says weigh the filter paper and record the mass. So I'm getting a piece of filter paper, but it's important that I know what this guy weighs all by itself because I need to be able to see how much heavier it gets when the precipitate's on it. So I'm going to take it over to my balance, zero out my balance, put my paper on there. All right, and my filter paper by itself, all right, weighs 0.60 grams. All right, so if you look in your data table, 1, 2, 3, 4, 5, 6 up from the bottom, you want that to say 0.60 grams. All right, now we've got the mass of our filter paper, all right, and they're walking us through how to prep the thing. All right, so they said, let's go ahead and fold it so that we can create a filtration system. So you take your paper, fold it in half. Okay, you got a half, then you fold it in half again, and you got a little pizza pie. And when you do that, you create a window that you can filter on the top. Middle's no good because it's open on both sides. And you've got a piece of filter paper for the bottom. All right, so we're going to use, doesn't matter which one of those sides to filter. Right, I'm going to take that and I'm going to wet the paper and I'm going to stick it into my funnel. When I do that, it's going to look like that. All right, now I'm going to take you over here because we are ready to start filtering. All right, so what you see here, right, is a filtration setup. I've got my funnel sitting on top of a ring stand with an iron ring, and then I've got a beaker underneath to catch my filtrate. All right, so what I'm going to do is I'm going to take my substance and I'm going to pour it. All right, and gravity is going to let that thing drip and drip and drip and drip and drip. Now, this is the part that would take forever, right? Sometimes it takes 30, 40, 50 minutes, depending on how much we have, and we had a pretty fair amount. All right, so what I'm going to do is I'm going to filter, all right, the last little bit from a beaker I had earlier, right? So this was what you guys saw from the precipitate. I've been filtering this for a little bit of time. I'm going to let that drip out is the last tiny bit of what you're seeing. All right, so even that is going to take maybe a minute or two. A couple things to note. When you look, and the reason this takes so long, if I look underneath here, it looks like that is not perfectly clear. It looks like a little bit of the solid has made it around my filter paper. Sometimes it's due to overfilling. Sometimes it's due to the filter paper having like wide pores or something like that. Sometimes you just flat out miss, okay? And it just makes it through here. So a lot of times what we'll do is we'll take this underneath and pour the filtrate back through to try and refilter it. And these are all the things that we would do in the lab to try to increase your yield of calcium carbonate. But for the purposes of the video, you are getting the idea of what's happening. All right, so we're letting this thing drip. And if I let you look down in there, you can see you're starting to get white solid. Sorry, trying to zero in on that. Caught on the filter paper. All right, so we're going to let that filter for a second, and then I'm going to show you where we're going next. What you do is you go in your drawer, and you're going to get out a glass plate. All right, that glass plate, all right, is going to get the filter paper. All right, and we're going to open it up onto the glass plate because we are going to take it to the back. And when I take it to the back, I'm going to put it in the oven in the back. All right, so we have the oven back here that you guys can see. All right, and I open the door, and there are shelves, and this guy's on. Okay. And what will happen is we'll have to put him in there for something like 5 or 10 minutes. And the whole goal there is we have got to get rid of the water that is still on the filter paper, because what's happening is if that water is on there, I think it's calcium carbonate, right? The weight that's increasing the filter paper is supposed to be due to the precipitate. So if I never dried the thing, it would be crazy heavy because a ton of water weight is in there. Right, so when you start thinking about sources of error, like not heating it till the point it dries is a big source of error, because now you would think you have more precipitate than you do, which is going to mess with your calculations. All right. From other sources of error earlier on, we had some transferring. I had to transfer some of my solid from my crucible into that beaker, right? A little bit of that solid might stick to the crucible. If it did, that's going to decrease the amount of metal carbonate I had. And if you start looking at where those are in your calculations, you can see, is that going to increase or decrease my yield? And those are some of the tougher problems that we look at. All right, so this guy's still dripping, all right, but I can give you a quick 101 on how that will mess with your error, just because you'll probably ask anyway. All right, so sorry, walking you guys around the room. All right, so if we go back to what we had up here originally, the whole goal is to get the grams of the metal carbonate and the moles of the metal carbonate. The moles of the metal carbonate come from this guy, the calcium carbonate. So anything that is messing with our precipitate in terms of error is going to mess with your denominator. of your problem. The numerator is the metal carbonate. So anything that was messing with this guy is going to mess with my numerator. And it depends on how it messes with it. So if some of this stuck to the crucible when I transferred it, this number is smaller than it should be. I'm going to get a littler molar mass than I'm supposed to. If for some reason extra solid got in there, there was something else in the crucible and I dumped it right in there, or something attached to it, water reattached to the metal carbonate, that's going to make this be heavier, which means I'd have a higher molar mass. Like I said with the precipitate, if I get the precipitate and all that filtrate was milky white, and there was a lot of white in the area underneath where it's filtered, that means I didn't collect all of the CaCO3. He's going to be small. And if he's small, he's on the bottom, right? When we convert him, if I divide by a smaller number, I'm going to get a bigger molar mass because I'm dividing by a smaller number. If when I heat the thing up to dry it off, I don't get rid of all the water, he's heavier. I'm going to have an artificially heavy number here, which makes me get a fake bigger number here. Dividing by a bigger number, I would get a smaller molar mass. So you really have to decide where is that factoring into the calculation and figure out what's happening with your numbers. So there's a lot of presentations to that. All right, so hopefully we got enough time that I can go back and we're done filtering. So let's take a look. All right, so show you guys what's going on. You look down in, there is a tiny bit of liquid there, but I think you're going to find it's not that big a deal when I take it off and put it onto the watch glass. All right, so we're going to go in the drawer, get ourselves some forceps. All right, so we're getting our forceps. Just retrieving this guy. Taking my filter paper out, I can gently touch it. And I'm going to open it up onto my watch glass. All right, so I opened the thing up. And you can see I have that on there. All right, so what I'm going to do is I'm going to take it to the back and I'm going to put it in the oven. All right, so go ahead, hang tight a second. And hypothetically, let's assume that that was long enough to dry the thing. I would bring the substance back up. And now I have a dry piece of filter paper, all right, that should have my precipitate sitting on the top of it. So the last thing I would need to do is get the weight of this guy. All right, so I'm going to take you guys over to the balance one last time. I would come over with this thing. I'm going to put it on my balance. All right, and I'm going to give you guys that number. And what we're recording right now, all right, is the CaCO3 with the filter paper. So we're about halfway down the table, all right, if we're looking at this. All right, that number, all right, with the CaCO3 on it, all right, is looking like 2.19. All right, so 2.19. All right, then what we would do is we'd put it back in and heat it one more time for another 5 minutes just to make sure. All right, so let's hypothetically say I did that, put it in there, heat it up. I'm going to mass it again. Now the number is 2.19 again. We have heated it enough. So your mass of filter paper plus CaCO3 should be 2.19. And then the mass of filter paper after the second weighting should be 2.19 as well. All right, and from there out, it would just be cleanup. All right, tearing that down. All right, so hopefully you guys have all you need between the video that has the pre-lab. I'm going to attach the directions to this lab as part of a Google Doc in the classroom, and you'll have all your pre and post lab questions. I'll make sure I attach the procedure as part of that as well. The thing that tells you what needs to be on the yellow pages, what needs to be, typed, and so on and so forth. All right, so if you have any questions after doing that, please message. Other than that, thanks for watching.